Hello folks, and welcome to tutorial number 7 of 8. The topic of this tutorial is factorial analysis of variance in SPSS. This tutorial is divided into 3 videos, and the objectives of these 3 videos are to help you compare independent samples with more than one factor, that is, more than one independent variable or predictor variable. We're going to specify null hypotheses and maybe alternative hypotheses. We'll check our assumptions using SPSS. Also using SPSS, we'll compute F ratios and omnibus effect sizes. This time I'm going to show you a way of getting SPSS to do the eta squared calculation for you. We're also going to conduct additional tests, that is, simple effects, planned contrasts, or post hoc tests as appropriate. Now, the simple effects analysis requires that you use the syntax editor in SPSS, and I've said previously that we wouldn't use syntax in Psych 202. It's not complicated, but you don't have to do it if you don't want to. You're welcome to skip ahead past that part of the video. One thing you might notice is that there's no objective related to writing these things up in APA style for this video. The reason for that is I hope you're all working on your practical report if you haven't already submitted it, so I figure you can probably use a bit of a break from APA style write-ups. To complete these exercises, as usual, you'll need SPSS up and running on your computer, your pink book, and factorial between groups analysis of variance is covered in Chapter 8, which begins on page 91. And the files data_8_1.sav, which is what we're going to use in the first 2 videos, parts 1 and 2, and the second example, data_8_2.sav, which is the illustrated example 2 that we'll go over in part 3. Now I'm going to post all of those on both of those on the topic 8 page on Moodle. So if you're all set, you've got SPSS up and running, you've got the file data_8_1 handy, and you're ready to do some analyses of variance. Let's get started. So factorial analysis of variance tests hypotheses about mean differences when there are 2 or more factors, that is, 2 or more predictor variables or independent variables if you're doing a true experiment. As with the last few topics that we've been covering, it's based on a comparison of sample means. Although the test statistic is a comparison of explained versus unexplained variance, just like we talked about when we talked about one-way analysis of variance. Unlike one-way analysis of variance, in factorial analysis of variance, we're evaluating both main effects and interactions. A main effect tells you whether a single factor affected those sample means in isolation. Field calls this the unique effect of a predictor variable on an outcome variable. And interaction effects examine the influence of 2 or more factors in combination. Again, Field calls this the combined effect of 2 or more predictor variables on an outcome variable. So a statistically significant result, a statistically significant F ratio, means all group means or possibly all marginal means, we're going to talk a little bit later about what I mean by marginal mean, are not equal for that particular effect. And in most cases, further tests are going to be necessary to determine the specific details about what is significantly different from what. Before we get started looking at some data in SPSS, I want to talk a little bit about factor notation. In factorial analysis of variance, studies are described, or analyses are described, as A times B or times C, etc., factorial analyses, where the number of numbers is the number of factors or predictors or independent variables. And then each number refers to the number of levels of one factor. So, for instance, on page 91 of the pink book, it says that 2x2 designs are the most common. 2x2 would mean you've got 2 independent variables or 2 factors with 2 levels each. So males versus females and young versus old. In a 3x4x5 hypothetical study, what you would have is 3 independent variables. One has 3 levels, One has 4 levels, maybe 4 doses of caffeine, and one has 5 levels. So each number refers to the levels of one factor. So that's where that 2 by 2 comes from in 2 by 2 factorial analysis of variance. So here's the first example, illustrated example 1 on page 92 of the Pink Book. To investigate the impact of both background noise and practice on adults' reading comprehension, a researcher divided a group of 30 volunteers into 3 evenly sized groups. Members of the first group were individually taken into a silent room, where half were tested immediately on a simple reading comprehension task, while the other half were given 10 minutes of practice time before testing commenced. Members of the second and third groups experienced similar treatment in rooms with either low levels of background noise or high levels of background noise, respectively. So the researcher wants to know if, first of all, if background noise impacts reading comprehension, if practice impacts reading comprehension, and also whether there is an interaction between background noise and practice on reading comprehension. And this on the screen is table 8.1 from page 92, which shows participants' reading comprehension scores. They're divided, so the first 15 participants are the participants who did not get to practice before they took their test. There are 3 groups within that group. 5 participants who took the test when there was no noise, 5 who took the test in the presence of a low level of background noise, and 5 who took the test in the presence of a high level of background noise. And ditto for the 15 participants who experienced, who got to practice before they took the test. All right, so based on the description on page 92 that I read to you just now and the details in this table, what I'd like you to do is pause the video here and see if you can figure out what the research question or questions are, what the independent variables are or predictor variables. See if you can work out the factor notation for this study. Think about the dependent variable, and finally, the null hypothesis. You ready? All right, give it a shot. All right, here we go. So if you answered that the research questions were these 3 questions in the middle of page 92, does background noise impact on reading comprehension? Does practice impact on reading comprehension? And is there an interaction between background noise and practice on reading comprehension? That's great. I want to illustrate to you one way you can kind of combine those 3 questions into a single question, and that is by asking what are the separate and combined effects of practice and background noise on reading comprehension. So what are the separate and combined effects of independent variable 1 and independent variable 2 on the dependent variable? Is the independent variables were whether the participants got to practice. They either got no practice before taking the test or they got 10 minutes of practice. And what was the noise level in the room where they took the test? It was either no background noise, a low level of background noise, or a high level of background noise. And in this case, because the experimenters were able to control which participants were able to randomly assign participants to a practice condition and to a noise level, those are both true experimental independent variables. This is a 2 by 3 factorial analysis of variance. It's 2 because there's 2 levels of practice, none or 10 minutes, and then 2 by 3 because there's 3 levels of noise, none, low, and high. You could also call it a 3 by 2 factorial analysis of variance. Then you'd be talking about noise first. So the order of those numbers doesn't matter. The dependent variable is reading comprehension score, and the null hypothesis in this case is that reading comprehension was the same for all groups. And in this case, we're talking about 6 different means. One way that we might like to sort of conceptualize those different groups is according to the different factors. And this is really easy when we've got 2 factors as opposed to more than 2. So what I've got here, basically got the 2 different levels of the practice factor, and then across my columns I've got the 3 different levels of background noise. So I've got 6 different cells because we've got 2 levels of one independent variable and 3 levels of the other independent variable. If we multiply those together, we get 6 total cells. So we're going to come back to this table, but if it helps you to visualize in terms of thinking about what are the factors, how do I express this in factorial notation, this is a good way of doing it. All right, so now let's take a look at the data file in SPSS. All right, now let's take a look at the data in SPSS. If you've not already done so, please open up data_8_1.sav. I'm going to start out in variable view. And you might notice, if you're following along with the pink book quite closely, you will probably notice that the data file that you have is a little bit different than the screenshot in the pink book. They have an ID variable. The participant ID variable is to help you keep track of the participants in the research. It's good to have. It wasn't included. If you want to add one in, you're welcome to do so. So our first variable is the practice variable, and you'll notice that it's a nominal scale. It's coded as a nominal scale variable, and it's got 2 value labels. So if the participants had no practice, they're coded as 0, and if they had some practice, they're coded as 1. Similarly, for our second independent variable, which is also coded as a nominal scale variable, that's the level of background noise. Now we've got 3 levels. So no noise was coded as 0, low noise coded as 1, and high noise coded as 2. And then the third variable in our data set is comprehension. So this is the reading comprehension score. Just as a reminder, each of these rows represents a different participant. Reading comprehension score and the conditions associated with each of 30 different people. Right before we can analyze our data, it's important to check assumptions. At the risk of sounding like a broken record, we've got the same assumptions for factorial analysis of variance as we had for one-way between groups analysis of variance, as we had for independent samples t-tests. That is that the scale of measurement is interval or ratio, and indeed, as far as we can tell, based on the information we've been given, it's reasonable to assume that it's an interval scale dependent variable. The second assumption is independence of observations. As far as I know, that's what that acronym AFAIK is referring to. These observations are independent. We've been told that there were 30 participants recruited, and we can tell that there were 30 different observations. So for all we know, as far as we know, those observations were independent. But again, that's a design issue, not something we can test with SPSS. To check the assumption of normality, we're going to do what we've done before, which is explore each of the different groups. What we need to do is evaluate each cell. If you think about this table, we want to evaluate each of these 6 groups. The way that the pink book asks you to do that is to split your file and look at, I think, these 3 groups first, so the no practice, no noise, low noise, and high noise, and then shift and look at these 3 groups. I'm going to do it a little bit differently, so if the way that I do it doesn't work for you or you don't care for it, just follow along with pages 94 and 95. And you will get the same results. It's just going to take you 2 steps instead of 1 step. Okay. So here we go into SPSS, creating a new variable so that we can evaluate all 6 samples with 1 explore analysis. Here we are. Like I said, I'm going to create a new variable, so I click transform and then compute variable. What I want is a variable that assigns a different number to each cell in that table of sample sizes, that factor table. So I'm going to call my target variable cell. So I'm going to open parentheses. I'm going to look at practice. I'm going to add 3 to each of those scores. So instead of comparing 0s and 1s, I'm comparing 3s and 4s. Then I'm going to multiply by noise level, and I'm going to add 1 to each of those scores. So again, instead of comparing 0s and 1s, I'm going to compare 1s, 2s, and 3s. So I'm clicking OK. Now I have a cell column, and you can see that if the participants had no practice and no noise, the cell column value is 3. They had no practice and low noise, they get a 6 because it's 3 times 2. If they had no practice and high noise, the cell column value is 9, 3 times 3. If they were practicing, the practice multiplier is 4 instead of 3, so we get 4 times 1 in the no noise condition, so 4 in the low noise condition, 4 times 2 is 8, and then in the practice and high noise condition, 4 times 3 is 12. So we've got 6 different codes, and just to make things nice, I'm going to add those value labels. So a 3 indicated no practice, no noise. So I'm going to say none, no noise. Then 6, a score of 6 meant no practice, low noise. A score of 9 indicated no practice, high noise. A 4 indicates practice, some practice. Whoops, I'm going to spell it properly. But no noise. I'm going to add that, and notice that when you add them, SPSS puts them in numeric order. So 8 is the value for the label some practice, low noise, and then 12 indicates some practice, but a high level of noise. I'm not going to check my spelling, I'm just going to click OK. Now when I go back to data view, cell column, you can see if it says no practice, then it's none, and no noise means no noise. So I've just taken these 2 independent variables and combined them into a single variable. So that means that I've got 6 different groups in the cell column. All right, so now I'm ready to explore my data and evaluate whether my reading comprehension scores in each of the 6 cells or 6 individual groups are roughly normally distributed. So we'll do that the way we've done it before. Analyze, descriptive statistics, explore. Reading comprehension is our dependent variable, so we put that in the dependent list. Cell is our independent variable, so we put that in the factor list. By the way, you can put multiple factors in the factor list. It gives you something a little bit different than what we're looking for, though, which is why I went to all the trouble of calculating that additional variable. You're welcome to look at stem and leaf plots if you like. I'm not going to. I am going to look at, just scroll through histograms quickly. I'm going to look at normality plots. Okay, so I'm going to click continue and OK. Now here's my output. As we've done before, you're welcome to look at descriptive statistics. Here's our test of normality. Remember, We don't want to over-rely on statistical tests of normality, but we can be reasonably confident if we don't have a statistically significant result that our samples are approximately normally distributed. And it looks like if we look at the Kolmogorov-Smirnov, we have no statistically significant results there. We've got one that is a little bit lower than the other estimates, but that's okay. Then if we look at the Shapiro-Wilks tests, we've got scores that range from 0.78 up to 0.95, 0.96 is the highest. And those p-values are all between, are all greater than 0.05. All right, so let's just scroll through and look at, here's the histogram for one group, the next, here's the third, and the fourth, the fifth, and the sixth. And then here are the QQ plots, 1, 2, 3, 4, 5, and 6. You can see how anytime you've got more than about 4 groups, it can get a little bit difficult to keep track of them. So it's good that they put the group that you're comparing in the title of the graph. All right, so at any rate, we've checked our QQ plots, our Shapiro-Wilks tests, we've looked at histograms, and there's no evidence of violations of the assumption of normality, which means that we can move on and conduct the analysis of variance. Now we're going to go back to SPSS, and we're going to analyze. And remember, we've been comparing means. We are still comparing means, but there's no way to compare means when we've got multiple predictor variables, multiple independent variables, using the compare means function. So we need to move down once. We've looked at this before with analysis of variance, and I told you we'd be looking at it this time, so this is what we're doing. Analyze, general linear model, univariate. Univariate means one dependent variable. Okay, so here's my univariate window. I've got the cell variable that I created highlighted, but I just want to point it out to you to say that we're not going to be using it anymore. It was just for exploring our data. So the dependent variable in this case is reading comprehension level. And we have options here: fixed factors, random factors, covariates, and weights. For Psych 202, the only box that we're going to use in this window is fixed factors. I was hoping to find a nice short explanation of when you use fixed factors and when you use random factors. I haven't found anything that I think would be helpful that isn't a whole textbook long. So suffice it to say, you might have random factors if you have a more complicated experimental or study design. For everything that we're looking at in Psych 202, we have fixed factors. So both our practice variable and our level of background noise are both fixed factors. So I'm going to highlight both of them and put them in the fixed factors box. Now I have a dependent variable and 2 independent variables, but before I can move on, there's a lot more work to do. The first thing I want to do is choose the second to last button and click Options. Now I'm looking at the univariate options. Notice there's a box for estimated marginal means. Again, we'll talk more about that in a little bit. For the estimated marginal means, we want to choose practice noise and practice asterisk noise. These refer to the main effect of practice, the main effect of noise, and the practice by noise interaction. We don't typically include that overall. That's just going to give us some more, that would basically tell us what the grand mean is. So we're going to display means for practice noise and practice by noise. We're going to want to compare main effects. When we look at confidence intervals, we're not going to do a confidence interval adjustment. And you can see that I've already got some options selected. I believe the default is all of them unselected. We're going to ask SPSS to display descriptive statistics as we have done before because it displays them in this output in a little bit neater, tidier, more compact a way than in the Explore descriptive statistics table. We want to test homogeneity of variance because that's an assumption of factorial analysis of variance. Notice here in the display function we have an option for estimates of effect size. So last tutorial we calculated eta squared ourselves using a calculator based on that ANOVA source table. We don't actually have to do that. SPSS will actually give it to you if you ask for it. We're going to get a lot of output to begin with now, so rather than generate even more output that we're not going to look at, let's just leave these three and not select any more than that. We're not going to change our significance level from 0.05. That means we will see 95% confidence intervals. You might notice that there's no tick box for Brown, Forsyth, or Welch's Fs. To sum up, in the univariate options dialog, I've selected both main effects and the interaction to display the means. We're going to compare main effects. We haven't altered the confidence interval adjustment. We're going to display descriptive statistics, effect size, and we're going to do tests of homogeneity and variance, and then we can click continue. But we're still not done. We're going to want to look at graphs. So the way to do that is this third button down, click plots. And what the pink book asks you to do is put noise on the horizontal axis and practice in the separate lines. What that's going to give you is a graph where the x-axis has no noise, low noise, and high noise as its different levels. And there's going to be two lines, one for no practice, one for some practice. Then we click Add. In addition to that plot, I'm also going to look at the same information plotted a different way. So instead of putting practice on the separate lines, I'm going to make practice the x-axis and look at three different lines for noise. So I'm going to add practice by noise. So I'm going to click continue. Now, we're not going to specify any contrast or post hoc tests or anything like that. So if you are not interested in using the SPSS syntax editor to look at simple effects, you are done. Go ahead and click OK, and I will meet you at the beginning of video 2 where we're going to look at the output that we generate here. However, if you want to follow along, go ahead. So for those of you who are joining me when we get to the output, please remember to save, and I'll see you at the beginning of part 2. Okay, for the rest of us, it's really not that difficult. What we're going to do is click the Paste button. Paste opens up the IBM SPSS syntax editor. We're going to add 2 additional lines of syntax, basically lines of code. So the place that we're going to add them is in between these 2 tables. So at line 7. Now, don't worry too much about what all of this is. This is just telling SPSS that we're going to run a univariate analysis of variance. These are the plots that we're going to include, so you might only have 1 instead of 2. These are the tables that we're going to include, and we're going to ask for a couple extra tables. So in between line 7 and line 8, where we're asking for the table that describes the main effect of noise and the table that describes the practice by noise interaction, I'm going to type the words that are in the middle of page 99, but I have to type in exactly what is written on those 2 lines. So backslash em means equals tables, whoops, practice boy noise, which we already have, and then the word compare, which you'll notice turned red. So now specifically what I'm going to compare is the simple effect of practice. And then I'm just going to copy and paste that, so Control C, Control V, and then instead of practice, I just need to write noise. So even though the two lines that I added are offset from the rest of the syntax by a little bit, that's okay. Now here, in place of going back to our univariate analysis of variance dialog box and clicking OK, I'm going to choose to run this syntax. So I go up to the menu up here and see we've got some of the same menus that we had before. Now we have this run menu. So I'm going to run all, and that's saying run everything, do everything that's coded into this syntax editor, right? So run all. And now we've got the output that we asked for in the syntax editor. Right? So if you haven't done so already, save that output, save your data. This is the end of video 1, and I'll see you in video 2.